I think there's a lot of also people who are AI enthusiasts right now, and probably they're in, I don't know, high school or college or whatever it may be, and they're seeing what's happening. They're looking at the news. They're seeing all the stuff that's coming their way, and they say, look, I want to jump on because I think this is really cool stuff, and I really could help the world in whatever I can. And what is your advice to them? Could be a few things getting into the space. What are there resources? Are there communities I can join? And what should I do to make sure that I stick out, so that when I do want to be hired as an engineer or someone who wants to be involved in AI, what do I need to show for myself that I've got what it takes to be in this space? What can you sort of say to that?
Well, I think that there's a lot of different ways that you can kind of come into AI as an engineer. I like to think about things from kind of like a principle standpoint. So one principle in engineering is that in order to become or achieve an expert level of proficiency at any level of the stack, you need to have a fundamental understanding, like you need to have a deep first principles understanding of the level immediately beneath it, right? So what does this mean? It means that if you're writing assembler code, you need to understand how transistor networks work and how they're able to actually execute Boolean logic. If you're writing C code, you need to understand how ASM works. If you're writing Python, you need to understand how C works, and on and on and on up the sort of chain of abstractions. When it comes to AI, what I'm seeing a lot of is I'm seeing a lot of people jump into AI and utilizing these models without actually understanding that one level below. And I think if anything, that's dangerous, because if you don't understand how these things actually work at a fundamental intuitive level, if you don't grok it, then you don't really know what you're doing. You're kind of coding by coincidence. So what you need in order to do that, I mean, listen, everybody's going to come at this different. For some people, the best way for them to engage personally is going to be to join some kind of group, right? For other people, it's going to be to go to school and get their master's in mathematics and then their PhD. For me, I'm always kind of, I can only kind of speak from my own perspective. I've always been very much like an autodidact self-learner type. What I just kind of knew would need to be done is you need to go really deep into 4 different branches of mathematics. You need probability theory, statistics, linear algebra, and you need calculus. Specifically on the calculus side, you're going to need to have a strong understanding of derivatives and partial derivatives. If you can get, the good news is you can get all that for free. Okay. There's Khan Academy. There's Wikipedia. There's ChatGPT, right? You don't even need to go to school. Just ask ChatGPT to teach you. You can even ask it to quiz you, and it will quiz you and it will grade your answers. It's ridiculous. What a time to be alive. So, but you need all 4 of those branches of mathematics to have a baseline understanding. And if you really, really want to become an AI engineer, regardless of whether you're kind of like just started college or maybe you're in high school, right? Maybe you're a freshman in high school. Math is really your thing. You kind of see the writing on the wall and you want to get started. Probability theory, statistics, linear algebra, calculus, get that all down. And then what you want to be able to do is you want to be able to derive stochastic gradient descent all by yourself. Okay. And then in Python, you want to be able to code your own neural network, not using PyTorch, not using Keras, not using it. No shortcuts. You need to code it from scratch. And if you can do that, you are well on your way to becoming an AI engineer.
That is definitely wise and sage advice for people learning. And yeah, you're right. I think AI has been democratized and it's now available for everyone's use. And
I'm not saying that's a bad thing.
Okay. Absolutely not. But I think that there's this element of like it's easy for people to jump into the space quite easily. So the friction has been removed. But at the same time, if you want to do good stuff, then just like anything, there are multiple abstraction layers to go through. And so it's not just one using the model that's given to you, but maybe understanding the model, why was the model created, understanding the processes and the fundamental thoughts that went into building the model, and then go from there. Because I think that it can be given in many cases to you on a silver platter, and I'll just use this. But if you don't know when to use the right model and in what cases and scenarios, that could be somewhat detrimental as well.
To your point, just understanding the fundamental limitations and knowing when it's time to train your own model. And if you don't have all of that math background, when it comes time to train your own model, you're going to be cracking the books one way or the other. There's no way around it.